Good day to everyone. We are from Group 5 under Section 2 for course Computer Programming. My name is Gilbert Yiltam, so I'm going to make an introduction regarding our computer programming project. Under lecturer Professor Madya, IR Dr. Shahrul Niza bin Mokhtar. So for our group members, first one, which is Atla Alessandro, second one, Junin Hosta Analidang, the third one, myself, Gilbert Giltam, Mana Davidson. So for the fourth one, that is Sharvin. For the fifth member of the group, Muhammad Zulfahmi bin Muhammad Zain. And last but not least, Roland Victor Parise.
Hello, my name is Atla Alessandro, and for today I will presenting my part, which is the overview of our projects. And first of all, our software will revolutionize structural analysis by leveraging Python programming's capabilities and structural understanding. Somehow, manual computation for solving intermediate beam can be cumbersome and error-prone. You can do a lot of mistakes. And for the solution, we provide an effective alternative, which is by using Python C++ coding. So, what is the objective of our project? We will try to acquire the skill to use computer programming in the analysis of intermediate beams. Our second objective is we want to utilize the moment distribution method, which involves adjusting the moment until a state of equilibrium is reached. Third, we will adjust the use of fixed end moment, stimulus factor, and carryover factors for calculating reaction force in an intermediate beams. And fourth is we want to enable user to enter force, loading, and dimension according to specification of the intermediate structure. And our last objective is we want to produce the output which will include the moment distribution and final support reaction values. Next is the scope of our projects. Who is our target market for this project if we want to sell it? So first of all, we want to develop user-friendly software which is accessible to students and structures engineers. And our second scope is we want to simplify calculation of reaction force in intermediate beams, because by using the manual calculation, it will be more prone error. For the challenge, what is the challenge or the problem statement in analyzing intermediate structures? So, first is degree of intermediacy. The complexity of intermediate beams increase with their degree of intermediacy. And the higher degree of intermediacy pose significant challenge for structural analysis. And for the second problem is complexity in civil engineering. Analyzing structure involves intricate calculation and consideration. And continuous beams with multiple span and support add to this complexity. With more complexity, it will be more prone errors.
Hi everyone, my name is Gilbert Giltam, Mana Davidson. So for my part, that is, I'm going to present literature review. So for the introduction, this literature survey will help provide guidance on how to apply the moment distribution method, appropriate for solving the study's indeterminate beams and frames. The literature study will explain a basic understanding of the moment distribution method and on how to apply fixed end moment, stiffness factors, and carryover factors in the calculation. So for the program introduction, we use Python as a language because Python can be used for creating as well. As well, it is numerous programs indicate that it is not restricted to resolving certain issues. Moreover, its interface is intuitive, facilitating ease of usage. This computer language will calculate reaction forces at different supports under various loading conditions, supported by a detailed output report which includes the distribution of moments and the final values of support reactions. So next I'm going to talk to you guys about what is the element that need to be calculated and what is the output of this program coding. So for the first one, simply supported beam. A simply supported beam is a beam that rests on two supports and is free to move horizontally. Typical practical applications of simply supported beam with point loadings beam in buildings. For the second one, forces of reaction. The force exerted on a structure when it rests against anything is known as the response force. Finding the reaction forces at the support because of the forces operating on the beam is a crucial step in the analysis of beam construction. As you can see in the diagram, for the first one, it shows that is one of the example for simply supported beam, and for the second diagram, it shows that there are few other forces for reaction. So for the other element, we need to calculate the shear force and bending moment. Shear force is a total of all transverse forces operating on both sides of a section of a beam. Determines the shear force at that point. So for bending moment, it is by calculating the value of shear forces and bending moment at a specific point of a structural element, such as beam, shear force, and bending moment diagrams are analytical tools used in conjunction with structural analysis to help perform structural design. So as you can see, for the middle part, it is known as shear force diagram, and for the last part, it is known as bending moment.
Hello, so my name is Junior Hosta, so I will talk about pseudocode. So what is pseudocode? Pseudocode is a readable informal language that was created to create computer programs by fusing basic text-based elements with conversational language. Because it doesn't belong to any computer language, members with and without technical expertise can both understand it with ease. Since the analysis by this project required several complex calculations with specific constraints, pseudocode is important in outlining a simple and straightforward logic of solution on the analysis of statically indeterminate beam by using moment distribution method in the early stages of planning and designing an algorithm. Okay, so let's start with the program details. First, we need to input the uniform distributed load for each beam span in kilonewtons. Make sure the values are numerical. If the load exceeds 100 kilonewton, you'll need to enter a value again within the range. If the load is less than 0 kilonewton, enter a positive value. The span should be entered in meters with its own numbers, within 0 to 10 meters. Once we have the loads and spans, we'll compute the stiffness vectors for each beam member. Stiffness vectors for each member A, B, BA, BC, CB, and CD are calculated using specific formulas. So next will be the support reaction at A, B, C, and D are computed based on the uniform loads and end moments. Reactions are derived from the equilibrium of forces and moments at each support. Input the span from point A to a specific point. Depending on the location within spans A, B, BC, or CD, we compute shear force and bending moment using specific formulas. Within these steps, you'll have a complete analysis of the statically indeterminate beam, including reactions, shear forces, bending moments, and bending diagrams.
For the next part, which is flowchart, we have two flowchart, which is the first and the second. For the second, first we need to print AB, BA, BC, CB, CD, and DC. Next, input A, which is 1, and 1 is equal to L, and input length, and calculate KAA equals to 0, which is KAB equals to 4EL over length. Calculate KBA, which is equals to 4EL over length, and KBC is equals to 4EL over length. And also calculate KCB that equal to 4EL over length and KCD over 4EL over length. Same for calculate KDC, which is equal to 4EL over L, and KDD equals to 0. For the process, calculate sum, which is sum KAB plus KAA equal to 4EI over L plus 0, and also the sum of KBA plus KBC, and sum KCB plus KCD, and also sum KDC plus KDD, which is also all the same with the equation for EL over L. For the last part, which is print sum KAB plus KAA, and sum KBA plus KBC, and sum KCB plus KCD, and sum KDC plus KDD.
Now I'm going to explain about the program validation. So we use moment distribution method. So for manual calculation, we use step-by-step iterative process to calculate the moment at joint based on stiffness and flexibility. So the advantage is it provides the fundamental understanding of structural behavior. But the disadvantage is it's time consuming, susceptible to human error, demand meticulous attention to detail, suitable for simpler structures or educational purposes. As for coding, the we automate iterative process using programming languages. The advantages are efficient and accurate for complex structures, allow parametric analysis, reduce risk of errors, enable quick design exploration, as the disadvantage is it requires programming skills. This is the table for comparing between manual calculation and also Python coding using Jupyter. So the difference between manual and coding are less than 1. Discrepancies may due to the rounding off values in the manual calculation, and there may be a small mistake, human error often occur in manual calculation. So the coding is to minimize such mistakes.
And for the conclusion, we can reduce the need for manual calculation. So after this, you will need less manual calculation. And for the second is, we achieve simple program to create and to calculate support reaction and member in intermediate structure, specifically beams and frames. And third is we use the moment distribution method with stiffness and carryover factor for structural analysis. And finally, the project is valuable for other users in their work field. Thank you. That's all from us.